All right, good afternoon. I'm kind of the last speaker before we have the beer, I think. Oh, there's beer. And then there's a panel. Panels are always fun after beer. I'm going to come back a little bit to some of the stuff that James talked about this morning, because I want to talk about it's not just microservices. I've been speaking about microservices now, I think about 3 or 4 years. And to some degree, you guys get it. I mean, the experience reports I'm seeing, when you're using it, a lot of understanding there. But we're still not getting necessarily the results I would hope to get in terms of productivity. And to some degree, this is a presentation that talks about those other factors. So it's not just microservices, it's a lot of other things. So we see if my fancy Bluetooth pointer doesn't work. Fine. All right. So I guess I'll stand closer. So if you don't know who I am, I've been doing this a long time. I'm old. That's okay. In fact, I wrote my first code in 1968, so it's been quite a while. Who was born before 1968? A couple, yes, right. So I've been writing code a long time. Basically, and certainly almost throughout my entire career, I've been sort of a change agent. I'm the guy who goes in and disrupts organizations because I bring a lot of usually new technology, new techniques, and abilities there. Kind of makes for sort of some troublesome times, but I also have a lot of fun doing this. I was also described, I think I've said this before to this group, I was described as the hand grenade being thrown into development by the Daily Mail, by the CTO of the Daily Mail talking to his boss. It says, who are you bringing in? I'm bringing in this Fred George guy. He's a hand grenade. If you ever get that job description, take it, because it's a lot of fun. So, so now she decides to work. There are a lot of industry hot topics. I go to a lot of conferences, probably not quite as many as some of my colleagues, but I see a lot of topics at conferences. So not only do you see microservices now as a track at almost every conference I go to, you're also seeing things like clouds and NoSQL database sort of things. In fact, we have entire conferences now around Docker and its hot topic. Cassandra, the technology that came from Netflix colleagues, event buses, sort of Nouveau Turkish. But we're also hearing about other things, like, certainly Agile's been out there a long time. We're talking about the lean startup, sort of like the business guys understood Agile, and they call it lean startup. And the whole concept of sort of minimum viable product is sort of a concept. So we're seeing business guys sort of get into these vogue topics, having conferences around these topics. And then you got whole things associated with new programmer roles, the way we should treat our programmers. And again, DevOps is extremely hot. Their entire conference is developed just to DevOps. I have some negative things to say about that, but there's a common theme here. It's all about going faster. Everybody at these conferences bringing these things forward, talk about how you can go faster with these things. And it really is a combination of these things. But the theme seems to be go faster. And that certainly has driven us and how I get to microservices as well. So a little bit of why we're here, and I like to use the Cynefin framework. Again, I've introduced this in the past to some of the audiences, so I'll go through it quickly. But the idea is you can classify problems. And basically, this guy named Dave Snowden, not the Snowden we all know and love, but another Snowden, he had a concept that, simple problems. Simple problems are those where the cause and effect relationship is very straightforward. If I raise my hand, you may speak. If you sit down, you don't speak. Those sorts of things are very easy to do. He said there are also the complicated problems. There's still a cause and effect relationship, but it's much more convoluted. It's the domain of the expert, the person who really understands accounting or really understands gene sequencing. Those are sort of the experts. But he also says there are other types of problems, complex, and he calls chaos or chaotic. The complex problems, there's not a cause and effect relationship. As much as you would like to think there's one, there isn't. Yes, because something happened, you can probably figure out why it happened, but that's not a predictor of the future. So your financial markets are this way. Google advertising is this way. Internet sales is this way. Recommending a book for you to read is one of these fuzzy types of problems. And these fuzzy types of problems cannot be organized the same way as complicated. You can organize yourself for one of these segments, but it doesn't necessarily work in another of the segments. And yet sometimes our management teams are ignorant of the fact that, we're working in a complex problem now. That complicated structure we had is not appropriate for this type of problem. So also, one of the things that Dave Stoner makes a point of, it says most problems you can't tell up front what it is. You may think you know, but that's just your prejudices. You need to watch the problem and how it behaves. So look for these cause and effect relationships. So we say about 85% of the time, in his experience, you don't know what type of problem you're trying to solve. You need to watch it and understand it, then react to it. The problem is, of course, you do have prejudices. If you happen to be a high-powered consultant, of course, everything's complicated because I can solve it. I'm just the expert. You have to hire me because you don't understand it. I do. If you're working on a complex problem, this guy's lying to you. He has no idea how to do it either. And you have to watch out for that if you're really working on a complex problem. In fact, in a complex problem, there is no concept of an expert. They don't exist. The customer doesn't know what he wants either. He says, this is what I should have in my feature set. He doesn't know. This is who I should lend money to. He's guessing. And you have to challenge him on these things. So first of all, you need to understand what type of problem you're trying to solve. And most of the times, the problems I've solved in the last almost decade have been complex problems. And to some degree, microservices works extremely well in that environment. Because going fast and trying things out is competitive advantage. And when I was working in a company in London, Forward Technologies, we made £50 million with 50 employees because we were solving complex problems faster than other people were solving them. And we gained a lot of money out of that. So going fast was a competitive advantage for us. So understand what type of problems you're trying to solve. And basically, we're working in complex domains now. When I was writing code in the 60s and 70s and 80s, no, we weren't. We were working on simple and complicated problems. Now we're working on complex problems, which is why some of the techniques I learned back in the 80s and 90s no longer work when I'm working these types of problems. So first of all, understand what type of problem you're solving, because frankly, all the new ones that are kind of fun to work on that make a lot of money, they're complex, not complicated. The other reason you want to think about this is you got competition hitting at your heels. And it's always been the case, but it gets worse and worse and worse every year. In our business in particular, there's two reasons it hits. First of all, there's technology available for your competitors. It used to be if you wanted to do a startup, you had to go buy yourself some Oracle licenses, get yourself a big machine, get yourself a large programming team, spend a lot of money in order to get into the business. You don't have to do that anymore. You can basically rent some time off Amazon or Google Cloud. You can bring some software up that's free, that does amazing things, and you're a competitor instantly. And a lot of companies don't realize how fast that their machines and their software and stuff is not protecting them from attack anymore because it's in there. But it's not only just the technology that's available to your competitors, it's also they have a way to find your customers. It used to be you had to have a sales force to find your customers. You know, the Oracles and the Alibabas still have large sales forces finding customers. But you can find customers through social networks. And in fact, you can sort of sneak in and steal customers from some of the biggest companies, and they'll never know what's happening until it's too late. And they look at their portfolio and say, well, why are all my good banking customers gone? Why am I left with sort of the dregs? Because the internet, through social networking, has found your best customers and siphoned them off. Looking at a startup in Amsterdam, and they were able to make money on checking accounts, on current accounts. They can make money. That's a money loser for banks. They can make money on it. They're going to siphon all those customers right off the top. So you got to watch out because the competitors are coming at you, and they're coming at you in very fast ways. And by the way, they don't have to be sitting in Berlin to compete with you. They can be sitting in Bangalore, running time off servers in Dublin, and basically attack you as well. So you're not invulnerable to world attacks. So you need to go fast. If you're going to, either you're going to go fast or your competitors are going to go fast. Very much as James was talking about this morning. So I want to talk a little about how fast can you really go. I mean, what is the limit there? And now I want to go back and reminisce a bit because I'm old and that's what we do. So I'm going to talk about how long it takes to do an iteration in the Agile age. And I'll say the Agile age starts around 2000. I did my first XP project, I believe, in 1999. The book was not published yet at that point. And so you look at this point, and basically there are a whole bunch of sort of Agile processes out there at the time. Scrum was there. We had about a 2 or 3 month sort of cycle time, which sounds kind of long now as we think it, but it actually was brutally fast compared to the times we were delivering host systems back then. Kent Beck's extreme programming was probably the fastest of all the processes. It talked about a 2 or 3 week iteration. We did the 3 week iteration sort of version in my first projects. One of the things we realized very quickly was that first week you kind of rest, and the second week you kind of work, and the third week you kind of panic. So basically what we decided we'd do was we don't need that first week anymore, so we cut it pretty much to 2 weeks, and then we actually discovered that panicking all the time is very productive. So we cut it down to 1 week. Yeah, you're sort of like, okay, it's money, oh my God, it's money we got to deliver on Friday, let's get to work. And it turned out it's a nice motivator. But we didn't stop there. You know, I kept working in other organizations. All of a sudden, it dropped down to a day. Our iteration planning meeting became our stand-up every day. You come into the work in the morning, you look and say, well, here's the work on the board that we need to work on, and who showed up? And we match them up. Because the work could have changed yesterday, the most important thing, and I don't know who's going to show up tomorrow, so I'm not going to plan for what's going to happen the rest of the week. That's nonsense. Let's react to what's here today. But we didn't stop there. Even the daily stuff became much more continuous. So let me draw another chart, another reminiscing chart. This one goes back even further. So this goes back to basically talking about product delivery cycles. How long does it take to sort of get something out the door? From the time you sort of conceive of it to get it out the door. So, clicker. I just ordered a new clicker on Amazon because I'm disgusted with this one. All right, this is a log chart, which means a straight line on this thing is really good because that really means it's aggressively going down. So straight lines are really good on this chart. So how long does it take to get something out? And let's go back to 1980. I was working at IBM at the time. I'd been at IBM working there for quite a while. And basically, I was working in waterfall processes. And I actually got an award in this time frame for a project I worked on 5 years before. And we finally had shipped it. It wasn't necessarily late, but we finally shipped it, and they went back and said, well, who should we give awards to? And I got an award for something I did 5 years before. I was also working on a project at this time where we had 1,000 programmers that had worked 3 years on it. Yeah. Well, don't worry about it too much. We made $1 billion on that software. So don't feel sorry for us. We did okay. But that was sort of the time frames we're talking about. A little later, I actually had a team of my own at IBM. I had a couple hundred engineers. And we sort of pushed the envelope to sort of push it out to 6 or 8 months between releases. And that was just brutally fast. And people say, well, why would you want our software? And we're like, well, we're listening to the customers, and we can ship this stuff out. We were actually we were driving it out from a test perspective, which was a little novel back then. I didn't understand how important that was. I left IBM about in that time frame and started picking up a little bit of object-oriented programming. And yeah, we got a little bit better, but still the release cycle didn't get radically better. But we're on a log chart. That's not bad. Then I picked up Agile around the beginning of the millennium. But again, my first Agile project, we were shipping every 3 or 4 months. My first ThoughtWorks project around that last yellow circle was my first ThoughtWorks project. And we had a 3-month delivery cycle. Yeah, we were running iterations at 1 and 2 weeks, but we still deliver every 3 months. But then, interesting enough, the bottom fell out. So what you see here is we have a hockey stick on a hockey stick chart. We're going brutally fast. And it's because a lot of the other things I'm talking about today, we finally got those other things right. And it wasn't just because of a process thing or just because of a language thing. So, yeah, I've shown this data before, but this is some stats about how fast can you go. This was our GitHub stats. We published our GitHub stats. And we basically were putting something new in production every 3.5 minutes. So you think you're going fast now? You can go faster. Every programmer is probably pushing something in production themselves twice a day. And by the way, feeling really good about it. They went home every night very happy because they did something today. And it wasn't attending a meeting. It wasn't drawing a UML chart. So, why aren't you there? So let's talk about the inhibitors. And there's 3 types of inhibitors I'm going to touch on. There's some technology inhibitors. We'll talk about those first because we're comfortable with those. Then we move into some process stuff. And then we're going to move to some really fuzzy organizational things. So one of the things that sort of you want to buy into this stuff is something that basically the CTOs and CIOs, especially in the US, talk about is Valley Tech. And what they're really referring to is the technology of these Silicon Valley companies, these Googles, these Facebooks, these Netflixes. What are these guys doing that we're not doing? And they'll be asking their IT guys that. And the answers they get, frankly, the IT guys don't like to give them the answers because they'll say, well, the other guys are using the cloud. Of course, we can't use the cloud. What? Why not? Or we're using specialized databases. We're not an Oracle shop. They don't use Oracle all the time. Well, it makes them faster, so we want to use Oracle. Why? Or they're using different programming languages. They use open source. It's okay to use open source. They're not afraid of it. And they're moving to this concept of continuously releasing updates. And it's like, well, we can only release like once every 6 months. Well, only because that's what you say you need to do. So basically, you need to begin to adopt some of these Valley tech, because this is what your competitors are building on. They're modeling themselves after the Silicon Valley startups. This is what they're building with. So another nice chart. This actually happens to be another log-based chart. And it talks about how long does it take to get hardware, because this turned out to influence a lot of choices that we made. So how long does it take to get hardware to run your application on? Well, if you go back to, again, we're doing 1990 at the starting point this time. Used to be what you had to do is you had to go figure out what hardware you needed and order it. And it took it 3 or 4 months to get in there, get it established, make sure it's running. 3 or 4 months just to get hardware in. And that's kind of a lie, because actually it was more like 18 months, because you had to plan for this the previous calendar year. You had to go into your capital planning budget at the end of the year, last year, and go allocate the money for anything you might need the next year. And guess what it is? And again, it was a big guess. And you better get it right. Fortunately, at some point, we decided we could take these real machines and carve them into virtual machines. So now I just have to allocate enough capacity for what I might need, and then I can carve it up as I need to later. And we got to the point where I could carve it up pretty quickly. You would take, you could go to your IT guys and say, I need another virtual machine. Sometime between a day and a week, a month, you might get it. That sounds like a really long time, but 2 years ago, I was with a hotel client in the US, and I wanted a virtual machine inside their enterprise. It took 3 weeks to get it. This is in this decade. We took 3 weeks to get it, and they broke the process to do it. Needless to say, they were in deep trouble. So we moved all from virtual machines into the commercial cloud. So along comes Amazon, and all of a sudden I don't have to go order that equipment early. I can go buy it when I need it. That's a radical change. In terms of hardware planning and stuff like that, radical change. Then, of course, along comes Docker, and now we get down to seconds. I can allocate, get a new container up, and we run a container, do one transaction, and throw the container away. We're going to be able to know the next time. And don't think twice about that sort of stuff. Now, this has an impact on how you work, because a lot of organizations still think about data centers. They still think about that hardware equipment budget, how much they're going to spend. So the whole concept of capacity planning is dead. If you're doing capacity planning for next year, you're wasting your time. You don't need to do that anymore. Yet I'll guarantee you probably have it in your large companies. And that also means that ops team, the people who know how to use this machine and set it up and keep it running, we don't need those guys either. They call themselves DevOps now because they want to hold on to their jobs. But in fact, we don't need the ops guys here at all. So yeah, I'm a little suspicious of a DevOps conference because that's just a bunch of guys getting together saying, we still have jobs, right? We still have jobs. Now that has a direct impact in the concept and evolution of microservices. I was talking to Richard Roger right before at lunchtime, and we sort of agree that all of a sudden microservices sprung up in parallel in many different places. I was playing with it in London. Clearly, the Netflix guys and Adrian were playing with it in Silicon Valley. But I see all these other projects coming up, and I've never heard of these guys before. And I don't think they ever heard of me. And yet, we kind of all came up with it. And it's because of that hardware curve. So it turns out, of course, when you got one big hardware piece, you probably need to allocate and figure out what you're going to write. And we write these big monoliths. I kind of call this a Rails and Java zone because that's where you write these big monolith things. And on this, and by the way, this is a log-log chart. So it's a really strange chart. So basically, a log-log chart like this, you have just one giant app, and it's going to be 100,000, a million, 10 million lines of code. When we started getting a little concept that was almost too unmanageable, SOA came along. It says, you can break this thing up. And I remember back in the day, I think Credit Suisse was one of the leading companies in this space. They took their 10 million or 100 million lines of code of inventory, and they began to break it up into about 40 or 50 services. So we're getting back down to reasonable-sized monoliths. And then along comes the cloud and Docker and those sorts of guys. And all of a sudden, you get what I call microservices. This is my view of where a microservice belongs. It kind of is in this zone. So basically, it's sort of like if you have 10 services, they ought to be less than 100 lines of code each. If you have several hundred services, it can be quite larger, but you're kind of in that zone. So the last monolith I worked on was in India back in 2004. I will never do that again. It's no fun. You can't make me do that. So that was kind of there. If you look at what we did at Forward, where we made all the money, that's where we were. We were basically sitting around 100 lines of code. We had over 300 services running. And we could react very quickly to things because we could deploy so quickly. I run a workshop that talks about some of this stuff. That was a workshop. This is Forward up there. So at Forward, we had about 300 services. The little workshop I run that talks about how to microservices, we write about 4 or 5 or 6 microservices very quickly in a day. The whole application probably takes 15 microservices. Very, very tiny stuff. And Netflix, according to what I hear from these guys, they kind of sit there. So they're kind of all in a microservices zone. And so this happens because of the hardware acquisition curve. And because it dropped out the bottom, people figured out, oh my goodness, I can write code in a different fashion. And again, sprung up in parallel in many places. So this is kind of why we're here and kind of why the microservices in particular happened. There's other technologies that are coming. If you've listened to me talk about various other things, you know I'm a big fan of event buses. I like the concept of a persistent event bus. It allows the maximum decoupling. It is one of the reasons we went very, very fast and forward, that we could get to this, because our coupling was very, very low among our services. And so it's a persistent bus. My favorite is Kafka. So it's a bus that LinkedIn uses. The open source, it's a wonderful Apache project, amazing online documentation of the tool. I usually hang a little services off there to sort of filter messages out, pull out the messages I'm interested in. Use a 0MQ to delegate those to corresponding services. Because one of the things about these buses is when they talk about a capacity of a bus, and Kafka's like 250,000 messages a second, they cheat when they count. All these guys cheat when they count. If you write a message and read it 10 times, that's actually 11 messages. It's not one. And so you got to be careful how many things you attach directly to these buses. And so that's why I put a second sort of tier there. And in most applications I've worked with, I've never needed more than 10 of these attached to the core bus, filtering out messages for myself. And what you wind up doing is you wind up attaching your service to one of these ancillary services, because these filtered out messages that you only need, that you care about, but you always publish back to the massive bus. So it's always available for any other service that cares to see it. And this makes doing things like building KPIs, building monitoring extremely easy. And by the way, it's made debugging extremely easy, because there's everything that happened. You want to know what happened? There it is, in order. Of course, this sort of architecture is yielding some new architectural patterns that allow us to write applications in a different style. And so you got to be aware that some of these new things are coming as well. So if you have a high-performance bus like this and you have a service, we have what's called the need pattern, which basically you set a service and say, I need something. Can somebody help me? Just put the need on the bus. Now, you have to be able to handle the case where you get no answers. Nobody wants to give you any help. So you got to be able to handle that case. And so you have to worry about that as well. In this example, I got 2 guys that do care about this message. They pick it up. They offer some solutions of their own. You pick up these solutions back off the bus. You pick the ones you like the best and use them. Now, this is a very powerful architecture, because one of the things is the blue guy doesn't know about the green guy, and vice versa. And by the way, I want to put out version 2 of the green guy because I have a better idea today. Let's try this idea. I just deploy version 2 of the green service in parallel. I don't have to go tell the other green service about it. I just deploy a new service. Let's try it out. Let's try. By the way, in the Cynefin model, in the complex, this is nirvana. And by the way, if the blue guy goes down, that's okay. The green guy's still getting some answers. Maybe not the best answers, but they're guesses anyway. I'm in that complex model. So it's very powerful for doing variations. It's very powerful for graceful degradation. Very powerful architecture. The downside is, of course, you have to worry about, I don't get an answer, and you need to worry, frankly, your algorithms are a little different than your traditional synchronous algorithms. But a very powerful architecture is available to you now. We've used that in a startup we did in California. We use this pattern to sort of build what I call incremental applications, where you basically get the application out there very, very quickly, and you keep upgrading it. Rather than sort of having this big bang, here's all the requirements, I'll deliver it to you that way. So we did this with something we call an offer engine. An offer engine is a type of application where basically you have a customer in front of you, but you want to sell them more. In the case of rental cars, you may want to get an upgrade or put a ski rack on it or something else like that. And so now that you have a customer in front of you, can you sell them more? The McKinsey guys call this share of wallet, which I think is a really clever term. They want to get a higher share of your wallet. That's the nice thing about stealing your money. So in this case, we did something this for a car rental example. And basically what we did was we put a high-performance bus in place. We put a little service up there to sort of put message on the bus that says, here's an opportunity to put some advertising on my site in that slot A and B. So I'll basically will do that, put a message on the bus. These two guys down at the bottom will offer some solutions to that. I'm up and running. And now I got some solutions. Fully running application, we're starting to make some money. Now I refined my algorithms. I add some more service into here. I'm going to check to see if you're a frequent renter with our service. If I know who you are from a login or something, and I know, or dropped a cookie on you, and I know who you are, I can tell you that you're a platinum member or a silver. Because it's competitive advantage, because if you're already a customer of mine, I want to hold on to you. It turns out it's much cheaper to hold on to you than to try to win you back. And so I should find some better offers. And so I'll do that information. These guys will make better offers because now they know you're silver or platinum. And then I do segmentation, breaking them up by segments. In the car rental business, if you rent a car between Monday and Thursday, chances are that you're a business renter. A discount's not important to you. That's a wasted ad. But a better car or points for your own vacation, a much better offer for you. And flip side, if you're a weekend renter, then you do care about discounts. So just looking at your rental car patterns, I can do that. I just add these services in, and I get a better answer. We implemented one of these systems for a hotel chain. We charged them $3 million to develop it. We made a lot of money there. And they made another $40 million in revenue in the first 6 months of this sort of system. They loved it. And they didn't care if they spent $3 million. They made $40 million. This is an easy decision for them. These sort of systems are very powerful, and again, incrementally easy to build. So you have that hitting you. The other thing you need to find from a technology perspective is the concept of databases. I think this is pretty well put to bed. Certainly the last presentation talked about that very nicely as well. Certainly the Fortune 100 typical view has always been, I want entity-level databases for operational stores. In fact, I want to have one consistent database to do that with. I had a conversation with one of the guys in the hotel chain. He was the chief architect. And being a troublemaker, of course, I sort of asked the question, well, how many operational databases do you have? And his answer was, I have 3, but I'm trying to get it down to 2. I said, that's really interesting, but your right answer is probably 300. It was the last conversation we ever had. That was okay with me because he really didn't understand. So what you really got to do is you basically want to, if you're going into this microservice business, you got to take that database and you got to blow it apart. And it is a holy grail of a lot of companies that try to do that. So I want to shift to an event bus because a permanent event bus is actually more powerful in my mind. And it's, you again, find several in open source. You put it in your database. If you need persistence in your service, you put it there in your service where you need it. You can certainly use whatever database makes sense. My experience so far, and it hasn't been a lot of experience, is only about 10% of those databases actually are writable. Most of the time it's a database you read, make some decision, and publish your information back onto the bus. And even fewer of that 10%, usually 10% of the 10% are actually transactional. And that's very powerful. Just because one service needs transactions doesn't mean we all have to use Oracle. We can use whatever we think is necessary. In fact, we can change our mind because it's my little database and I change my technology, deploy a new version of the service. So this comes in insidious fashion. So going back to this example again, if you sort of open up that little service that's supposed to put something on the net and look for answers, he has one little container running called event publishing. That basically his job is to, if a page comes up, publish something on the bus. End of his job. And then you got another guy sitting there listening to the bus, collecting all the solutions he gets back, and puts them in a Redis database. That's the end of his job. And the guy that needs to respond is going to wait 300 milliseconds if you're working on IE6. You're going to work 300 milliseconds and say, okay, whatever's in the Redis database, I'll pick among those answers. But by the way, I keep accumulating those answers in Redis, so the next time Sally comes to this page, I got a better set of answers. Works very nicely. But I'm running 4 different containers in one microservice accomplishing this. And it's got its own little database. It happens to be Redis because I like the key value, I like the way it sort of caches very nicely. Open up the membership service. Again, this service basically says, oh, if I know who you are, I'll put your status back on the bus. And so basically that looks like this. If you open it up, there's a little piece of code that's looking at the bus, waiting for, to hear about Sally. And if you see Sally, we'll look up the key value store because that's all you need. And push it out there. Now, how do you get the key value store? Go to your data warehouse and you strip it every night. It's another little process I'll run overnight, a cron job. They basically go do that and rebuild a key value store every night. So what if Sally all of a sudden does something right now that turns her into platinum? I'm going to wait till tomorrow to give her a better deal. Could I give her a better deal now? Sure I could, but why would I spend that extra money? It's good enough. I'm just guessing what she's going to buy anyway. These are guesses. And because it's fuzzy, I can worry about eventual consistency and be perfectly happy with it. And that's what a lot of the database guys don't get, is that when you're solving complex problems, you're working on guesses, eventual consistency is enough. So again, a little database for each service. The other bugaboo, clearly, for a lot of people, is open source. Thank God we got some guys, especially in this audience, that are contributed that, Netflix is out there. Oh my God, what an amazing stack of technology. Almost all open sourced. It is, in fact, the platform that we're building a lot of big applications in the States on, probably in Europe as well. If I had to go build another big application, that's the stack I would start with. Because it's clearly industrial strength, and it's been proven, and it's being used by others. Of course, everybody knows about the other open source technology key, and that's Docker itself. It got us from like 5 minutes to sort of virtual machine down to 5 seconds. And again, we're beginning to work, and work very differently with that. So don't be afraid of open source. If you're afraid of open source, you try to do this stuff yourself, or you're going to manage your own IT group, you will get killed by your competitors. One of the earlier speakers talked about there's no silver bullet. Yes, there is sometimes. Again, I will talk about my experiences, but you look at what's going on here, look at some of the key middleware we talk about. Kafka's written in Scala, not in Java, not in C++. It's written in Scala. And RabbitMQ, I think it used to be written in Java or C++, I don't remember. But now it's written in Erlang, of all things. And it's now super reliable because it's using Erlang. You scratch your head and say, well, why is that? These are very key pieces of technology, and they're using some very strange languages. So we had an experience when I was working at the Daily Mail. We basically wanted to render pages, and basically it was a big Oracle application, Java stack, some proprietary Java RPC mechanism. It was, really a mess. And it was over actually just rendering the Daily Mail pages, not even trying to do the editing of them, but rendering the pages was 130,000 lines of Java and J2E, Java JSPs and stuff. And 2 CTOs had come in and tried to rewrite this mess, had failed and got fired. So we came in there, this is where I became the hand grenade, and we basically rewrote the thing in 4,000 lines of closure. So there are certain applications, and believe me, there's some silver bullets out there for these sort of things. In our case, we were basically taking JSON structures of what we wanted the page to look like and wanted to convert it to HTML, which is just another structure, right? Transforms and functional programming. 4,000 lines of code, we're done. Delivered it early versus getting fired again. So there's some silver bullets out there, and if you're not using them, your competitors think about them. So that's kind of the technology side of things. Let's move on and talk about process. Because frankly, some of the process stuff we've sort of inherited from Agile isn't quite right for the microservice world. So first of all, you need to understand, going back to this model, you should understand what type of problem you're trying to solve. Certainly if you're solving a complicated problem, I'm not sure you're going to get much advantage out of microservices. If you're doing bank statements. I mean, there are rules about how you can't sort of do a fuzzy bank statement. You probably want the balances exactly right. So it's a complicated problem. I'm not sure you want to go that way. But if I want to decide whether I'll loan you money or not, whether you're a good risk, that's a fuzzy problem. And you want to attack that differently. So understand what type of problem you're trying to attack, and then think about it from there. The other part is we're trying to change the vision of what we're trying to build. It used to be that we sort of put our requirements in stone tablets, and this was it. And to some degree, myself and the 2 guys that raised their hand as being as old as I am, that's our fault. We taught the customers to go write requirements. Back in the early 70s when I was writing code, I started to start with the customer because a big application was 2,000 lines of code. That was big. You could do that by myself. I don't need to have any, what's business now? Why do I need somebody else? I'll talk to you. we'll implement the application. But over time, we got harder and harder to do this. We told you to tell me what you want, go away, please. We taught the customers to write requirements and give them to us. That's our fault, or my fault, not your fault, you're too young. But you inherited this problem. This is wrong. And especially solving complex problems, you do not know what you want. And so we want to move to a different paradigm here. We want to move to trying ideas out. That's what you want to do in a complex environment. You have an idea, let's try it out. Even if I'm a programmer, I have an idea where I can make some more money, I should be able to try it out quickly. And it's a competitive advantage being able to try things out very fast. This is a huge shift for the organization and how you want to work with your customer because it's a big shift. I do believe, and this is a saying that came out of Forward from a couple of our programmers, experimentation drives innovation. I love this for a couple of reasons. First of all, experimentation implies we will try things and fail. That's to be expected. And a lot of the organizations I've been in, part of my job is when we try something that doesn't work and somebody gets upset, a customer gets upset, I tell them to shut up. We're not going to slow down because we failed. I'm not going to let them try to get the programmer in front of them and yell at the programmer and he stops doing anything crazy. He's going to use Java the rest of his life. No, we're not going to get stuck with that. So we've got to move to a mode where we're trying ideas out. That means also we got to rethink how we interact with our customer around these ideas. So back in the day, and the picture's about over 10 years old now, I did this while I was working with ThoughtWorks with a very bright colleague, Greg Reiser. And Greg and I drew this pyramid. It says, everybody talks about stories as being the way we interact, and we break stories down into tasks. So most of your Agile processes have some elements like that. But we said there's higher levels of stuff, the things we would call features. Features are sort of part of projects, and projects are tied to some overall business initiative. And the ability of Agile to sort of trace everything I'm doing back to some business reason is a very powerful thing. It certainly helps with the Subordinate-Oxley, the SOX stuff you get from the States. So most of your Agile process says this is the point you interact with people. We interact at the story level. So the customer tells me what the stories are, he prioritizes the stories, we size the stories, we measure the stories, we do everything around stories. That's the theory. As I go through and looked at Agile projects, and I've done that for over 15 years now, a lot of time you see people working at the task level. So the whole stand-up is about what tasks did you work on yesterday, and what tasks are you going to work on today, and how long did you take on that task? And all of a sudden, the programmers are like, I have no idea what I'm trying to accomplish other than make sure little balls move across the chart. Because I have no idea what business value associated with that. In fact, they get very demotivated, and frankly, they don't want to be programmers anymore. This is the level of interaction we're pushed at now. We come and it says, don't tell me about stories. That's too low a level. Tell me what you're trying to accomplish. Tell me the features you want to accomplish. Come to me as a customer and teach me your domain. That'll be your job. Because when it comes to figuring out how to make money or do whatever it is, I'm really good at algorithms. You tell me your KPIs, I can play the game. So we've raised our interaction level to the feature level and changed our interaction model with our customers. Is to come talk to us about what you're trying to accomplish and then, frankly, get out of my way. A lot of this also, the good news is if I'm delivering twice a day, he doesn't have to get on my way very long because he's going to see a stream of functionality. And it's a whole different interaction measure with him. The other thing is we need to measure what counts. I've been measured about so many different things in my life. Lines of code, function points, you name it, I've been measured against that. These are really nice, and I tell you, whatever metric you put on me, I can game it. In fact, that's it's kind of fun. We game these measures. It's part of the entertainment value for us. So it turned out when we started putting actually the business metrics out there, how many clicks did you get, what's the page retention time, whatever your key metrics are, I'm perfectly happy to play the game there. And by the way, when we started playing the game against the business metrics, oh my God, we have new ideas that made money. Ideas that did not come from the business. So measure what really counts. Don't get yourself caught up in these artificial measures, or how many stories did you finish and how long did it take you to do the stories. Nonsense measures. Let's measure how much money we made. Let's look at the business value of what we've done. So a big shift in process. Raise the interaction level of the customer, get away from tablets of stone. Let's move to ideas. Organizational inhibitors. These are the ones that are toughest to wrestle with. I do wrestle with these because they're the ones that give me, create really positive environments for our customers. So the first problem I always see is over-specialization. That we have too many specialists associated with doing things. So a quick case study around that stuff. Well, the theory behind it, of course, is that specialists are very productive. They're the best at what they do. So let's make sure they're doing their stuff they're best at all the time. Great theory. The hard part of that is, oh, by the way, there is overhead of communication. James talked about this morning in terms of his chord charts. That communication, somehow we don't count that for some reason, about the overhead, how much that cost us. And we certainly don't talk about the working balances. I haven't got enough front-end programmers today. Oh my God, what are we going to do? We have to sit around, we're back in. We'll wait till the front-end guys catch up. Or vice versa. Or the poor database guys. He can't make your database up. So the problem, of course, is the specializations we talk about, particularly the waterfall titles of architect, designer, developer, and tester, which are steps in the waterfall process. We've institutionalized those with titles. I always thought titles were very, very demeaning at some level, because if you have a title on your business card that says, I'm a project manager, we all think you can't do anything else. Whatever your title on your card says, basically you'll tell people you can't do anything else. That's the only thing you can do. And that's not true. We can do other things. So a case study in particular. So this again comes from the Daily Mail. I showed up, again, the hand grenade showing up. There were 50 IT professionals between ops and QA, a few scrum masters, and some developers, both front end and back end. I found 25 more titles. You laugh, go count your titles. Yeah. And in particular, I found 0 people who knew what we're doing. Wasn't their job. The poor scrum master would be at the board every morning trying to see if all the pieces fit together. And she's a scrum master. She's not a technical architect who didn't understand what's going on. So the first thing we had to do is basically we need to fix the titles. So that's what we try to do, is let's go in there and fix these titles. So the way I attacked this is I first of all, let's define what we really care about, our key technologies. And I'm a fan of bad news. I'm a fan of the master, journeyman, and apprentice model, 3 levels of tiers. We then went through and identified what we consider key technologies for our business. It was Ruby, it was Java, it was iOS and Android, databases, testing. I try to get that off the list because testing is part of your development job. The CTO didn't let me do that. Actually, I tried to kill Java as well. He wouldn't kill it either. Object design, Node.js, front-end JavaScript, and the like. And then we went through and said, okay, we're going to redefine our job titles based around your competencies in these technologies. And so we create new titles based upon that for all our new projects. Now, the old projects were fine. You keep your title. But you want to work on our new stuff, these are your new titles. You don't have to work on our new stuff. You can stay on the old stuff. We've got lots of it. But you want to play in our new game, these are your new titles. So we call yourself a developer if you're competent in one of our technologies. Competent being that middle tier. Competent means I could probably code in Ruby all day long and not make any really bad mistakes. That's competent. We created a title called graduate developer. It means you're not competent. First of all, I'm not sure I hired you. If you can't do Java, you can't do front-end pages. I'm not sure why I hired you, but okay, it's free. I'll put it on the chart. Senior developer, he's a master at what he does. And this is, again, traditional path. You're a super front-end designer. You're a god in iOS, whatever it may be. That's very traditional. So you're an expert in the technology. And of course, experts can do amazing stuff in their technologies. And this is where we got a little crazy. We redefined another title called system developer. System developers themselves were competent in 5 to 7 technologies. They were full-stack developers. I call them poly-skilled. And we pay them the same as we do the experts because we value them. Frankly, a system developer is a guy I can give a problem to. Here's a problem to solve, and he knows how to cut the database part up, the front-end part, understands how the interaction should be, etc. He doesn't need a lot of help. Now, when he needs some help, he knows he needs some more help, he goes get the expert. But these are the guys you could build your team around, is these system developers. And just for fun, we threw in master developer. Again, didn't have a lot of those, but says I'm a wizard at between 3 to 5 key technologies. So you had a choice in your career path. We said, here's a choice. If you want to be a system programmer, just poly-skilled, and you have no iOS skills, fine, let's put you on an iOS team. You'll develop those skills. We'll invest in you to build you become a system programmer. We want those guys. So I take this to human resources. Now, the Daily Mail was founded in 1895. It's now owned by Lord Rothermere, the fourth Lord Rothermere of his title, English Lord. So what do you think human resources said when I walked in with this? Yeah, you would think. They loved it. Surprised the hell out of me. Yes, it surprised me because I was expecting holy wars. But they're like, oh, I've been trying to get out of this business forever. All these titles, I don't know how to rank people. People come to me and say, I want to be promoted. And I'm like, how do I even do this stuff? We're policing this as programmers. We decide when you're competent. We love this stuff. So we put it in place. Then just to sort of keep shaking things up, people were sitting in cubes. Sitting in cubes is a really bad idea because we basically want people to communicate. So James Lewis this morning was talking about Tom Allen, the guy doing the research about communication. I studied under Tom Allen in my graduate school. One of the things he said was the chance of you and I communicating varies inversely with the square of distances between our chairs. So you want people to communicate tightly, you sit really close to them. And so that's what we did. We tore down, this is from India when I did this in India, but we basically tore out the cubes and put in tables. We didn't actually build our own tables in London, we actually bought them. But we got rid of the cubes and put in tables. And we moved people dynamically to where they needed to be. Also, I took a cue out of this particular book, non-dedicated leadership. Do you need a dedicated leader, full-time manager? This is a great book. I'm sure most people have read it at this point, but sort of a sociological book or anthropological. But one of the things it says is a village never needed a full-time leader or chief of the town until he got to about 120 people. Certainly they don't need it at 10, have a dedicated leader. That was not required. If you got 10 people, then basically what? The leader's in the field working with everybody else. If he needs to be a leader for right now, he goes be a leader right now. But otherwise, he's working in the field with everybody else. And so that's what you want to have happen. So you notice in that title structure, there was no chief programmer, there's no team lead, there was no manager. We didn't have those guys. We said, here's a problem to solve, feature level interaction, go figure it out. Leaders will emerge by themselves. Because we're social animals, leaders do emerge within your groups. You don't need to go anoint the leader. You don't need to do anything special. They will find them. The other thing we corrected was the idea that I want to keep forming projects all the time. So we decided, instead of forming projects, especially for really short duration things, instead of putting our spreadsheets together, pull a project team together, then reform another project team, reform another project team, we want the teams to be stable. We will bring the work to you. So we have a stable working unit, and we bring the work to them. Again, James talked about the U.S. Marines and the way they tend to organize themselves. They give these Marines, a group of Marines, says, here's a problem to solve, go solve it, and walk away. That's what you want to do with these groups as well. So if you got some ideas, come sit with us as a customer. Bring your ideas to us. Teach us your domain. We'll do your features for you. And then, if you run out of money, we'll bring in another guy, tell us about his domain, and we'll start writing code for this guy. But we're not switching the team. Because teams take a while to gel and learn how to do things well and use their tools well, and you do not want to disrupt that communication. So that kind of wraps up my sort of recommendations and inhibitors about technology inhibitors, process inhibitors, as well as the organization inhibitors. So if you're getting into microservices, you don't have to do all these other things, but you better pick several others to do. If you're just doing microservices, go see how that works out before you try these others, you will fail. So pick something else. Pick some sort of managerless process to use. Certainly make sure you understand to use Docker in the cloud. DevOps, as much as I think it's a silly title, you need to bring those ops guys into the teams, and et cetera. And love your full-stack developers. Give them a lot of love. A guy who can do front-end and back-end, you want him to do those things. And if you do all that right, then you wind up with sort of the phenomenon we saw before, that you get this really wonderful hockey stick on a hockey stick. And all of a sudden, you're just cruising along and making scads and scads of money. So that's the story I have for today. I'm pretty much exactly out of time. Yep, pretty much exactly. I'll certainly hang around for more questions, and I'll be around certainly all day tomorrow as well, and probably have some beer as well downstairs. So thank you very much. So what is next?